This is 7.8, phase shift sinusoidal curve fitting. So the first objective we're going to look at, we're actually going to graph sinusoidal functions of the form y equals a sine omega x minus phi plus b. So just as before, the a is going to be the amplitude. And period is t, which is 2 pi over omega. So both of these are found the same way we did before in 7.6 and 7.7. And I have to mention before I move on, sinusoidal functions means we're looking at functions such as sine and cosine. And the reason why cosine is sinusoidal is because if you look at the graph of sine, and I'm going to graph this really quick, pi over 2, pi, 3 pi over 2, and 2 pi. And right now I'm just working at drawing the parent function. So the parent function of sine, we know, looks like this. So let me go ahead and put this in. So in blue, we're seeing the sine wave. So I'm going to put sine x. And then if we graph cosine, cosine looks like this, and that's going to be in red. So if I graph cosine, it looks like the sine wave, except we have pushed the sine wave over pi over 2 units. So that's why both sine and cosine are considered sinusoidal functions. The phase shift, this is something new that we haven't seen yet. We can find that by taking phi divided by omega. So if you look at the formula up here that I'm just highlighting, it says omega x minus phi. So that phi will shift the graph either to the left or to the right. And I want you to notice that there's a negative sign right here, not positive. So that's the generic or standard form. The other thing that's going to affect this shift is omega. So that's why when we look at phase shift, we're going to take phi over omega. If you know the phase shift, then you know where one cycle of sine starts. And to figure out the endpoint, what you're going to do is you're going to add the phase shift plus the period. So that's where they got that formula, phi over omega, that's the phase shift, and 2 pi over omega is the period. So here's an example. If we take the sine wave and we move it to the right, that shows a phase shift. So the phase shift is given right here. And then the period is still going to remain the same. So this period is 2 pi over omega. But the ending point is the phase shift plus the period. Okay? So below in this yellow box, you're going to see some important things. For starters, if we're talking about sinusoidal waves, it can be sine or cosine. So the standard form is y equals a sine omega x minus phi, or y equals a cosine omega x minus phi, where omega is a positive value. So the amplitude is still a, and notice it's the absolute value because we always want amplitude to be written as a positive. The period is 2 pi over omega, and the phase shift is phi over omega. Now, if you have phase shift to the left, that means that omega has to be less than 0. So omega has to be negative. And if there's a phase shift to the right, that means that that phi, and I hope I didn't say that before, phi is greater than 0. So phi has to be positive. Okay? So just really quickly, if I had this equation, y equals, and let me switch this over to a blue marker here, 3 sine of 4x minus 3. And I had to find the phase shift. I would use the formula phi over omega. So phi is this value here. So remember, the standard form has a negative here, and we have a negative here, so phi is actually a positive 3. And omega is the value in front of x, which is 4. So my phase shift is going to be 3/4. So here's another example. Y equals 4 cosine of 3x plus 2. And now I'm going to look for the phase shift for this one. So once again, if I'm looking for the phase shift, remember it is going to be phi over omega. Phi in this case is actually -2, because remember the generic form or the standard form has to have a negative in it. So to get a positive 2, I have to have a -2. So that's why phi is -2, and omega in this case is 3. So the phase shift is -2/3. Okay, so there's 2 quick examples and showing you the difference between a positive phase shift and a negative phase shift. So for this next one, it says find the amplitude, period, and phase shift of the function. Graph the function. Be sure to label key points. Show at least 2 periods. Okay, so if I look at this, I have y equals -5 sine of 2x plus pi over 2. The first thing they're asking us to do is find the amplitude. And remember, the amplitude is a value in front of my trig function. So I take the absolute value of -5 and I get 5. So the amplitude is 5. The period is 2 pi over omega. So 2 pi over omega, which is 2. That's the value in front of x. So the period is just pi. The phase shift. The phase shift is found by taking phi over omega. Because we have a plus inside of the parentheses, I know that my omega, or excuse me, that my phi is negative. So -pi over 2 over omega, which is 2. So I get pi over 2, which is negative, times 1/2. So this equals -pi over 4. By the way, this is my starting point. So this is where one period of sine, in this case, starts. And I had to find my 4 key points on the x-axis. So you have a couple of choices. You can ignore the phase shift and then just shift everything over pi over 4 units. And before we start, we want to get an ending point as well. So my ending point can be found by taking the period plus the phase shift. Okay, so the period, remember, we found was pi, plus the phase shift I just found to be -pi over 4. So if I do the math here, I find a common denominator. And let me just rewrite that so it's a little bit more clear. So pi becomes 4 pi over 4 minus pi over 4, which is 3 pi over 4. So that's my ending point. Okay, so I have my ending point, my starting point. So once again, if you ignore the phase shift, my 4 key points, I would take pi and I divide it by 4, and that would give me my first point, because I take the period, divide it by 4 equal parts, right? So the second one is going to be 2 times that value, which is going to give me pi over 2. So the third point is now going to be 3 times pi over 4, which is 3 pi over 4. And finally, the fourth point would be 4 times pi over 4. Now that better come out to be pi, which it does, because that's what it would be if I didn't have the phase shift. So once I found ignoring the phase shift, now I'm going to add that to the 4 key points. Okay, so the first point, remember we've shifted. So the first point is now negative pi over 4, right? So I look at my first point and I take pi over 4 minus pi over 4 to get 0. So here's my second point. And now we're going to take that third point, which was 3 pi over 4, and subtract out pi over 4. And when we do that, we get 2 pi over 4, or just pi over 2. And then our fourth point was pi. So pi minus pi over 4 will give me 3 pi over 4, and that's where we should end. Okay, so these are the new values. The next thing I'm going to have to do is graph all this. So remember the amplitude is 5, the period is pi, and the phase shift is negative pi over 4. If I'm going to graph this, I want to graph first the positive one. So positive 5 sine of 2x plus pi over 2. Okay. So if we're going to graph that out, I would use those points I just found. So let me write those in. So negative pi over 4, 0, pi over 2, and 3 pi over 4. Remember the amplitude is 5 and negative 5. So this would look like this because I'm taking the parent function and graphing it on top. And I'm going to need another point here because I need to come back up around. So to figure that out, you can check the difference between values, but if you notice the value change is going to be, and you can find this by taking 3 pi over 4 minus pi over 2. So I'm just changing this to these values, and it's pi over 4. It's the difference between the two. So if I add 3 pi over 4 plus pi over 4, I get 4 pi over 4, which is just pi. Okay, so I want to go ahead and label that in. Alright, so now that I have that graph, it should be pretty easy for me to graph y equals negative 5 sine of 2x plus pi over 2. All I have to do is multiply all those values that I got. And when I mean multiply all the values, I mean multiply all the x values by what I got by a negative 1. And that'll give me my values because it's negative 5. So that means everything gets flipped over the x-axis. So let's go ahead and do that. So 0 times negative 5 is 0. I had a positive 5, but remember we have a negative 5 now, so that value becomes negative. 0 remains 0. Negative 5 becomes a positive 5, and finally back down around. So all I've done is flip-flop this over the x-axis because of the negative hanging out in front of the amplitude. Okay, so this is my graph, and now it's asking me which one of these graphs match up. So if I look at the first one, it kind of looks like ours, but not quite. So let's look at, actually the first one, it's hard to tell because of the way they have these written out. So let's look. Okay, I think it's A, so we're going to go with that, and there we go. Okay, by the way, I'm not going to ask you to graph something with a phase shift, but I will ask you to find the phase shift, so just to let you know that the graphing portion won't be on the test, but, you know, if you know how to do it, great. Okay, that's the end of the chapter and the end of this section.